At around 50 million kilometers square, the Borealis Basin is by far the largest basin on Mars. It takes up about a third of Mars's entire surface area. The surface area of dry land on Earth is 148 million kilometers square. That is nearly the same as the surface area of Mars. So then that also means that this basin is about 1/3 the surface area of all of dry land on Earth. Because this huge basin occupies the northern hemisphere, it is also known as the North Polar Basin. This topographic map of Mars shows the drastic difference in elevation between the southern hemisphere and the northern hemisphere where the basin is. In general, the Borealis Basin is around 5,000 meters below the elevated southern hemisphere. It is also much less cratered. One idea as to how this contrast formed between the two hemispheres is through a single large impact. Although there is very much a lack of circularity when it comes to the Borealis Basin, that is because the massive Tharsis Plateau possibly came after the impact that formed the Borealis Basin. As the Tharsis Plateau started rising, it possibly buried the flat plains of Borealis and also obscured the circularity of the basin. There are many other ideas as to how this basin formed. However, at the moment, there is no definitive answer as to which one is correct. This massive, flat plain is currently the most well-investigated place on Mars, as pretty much all of the successful landers and rovers either landed directly in the region or at the outskirts of the region. This topographic map showcases the location of all of the man-made things that landed on Mars. Pretty much everything that isn't in the Borealis Basin region is a failed mission, although there are some failed missions in the Borealis Basin as well. NASA's Viking I lander is the first successful lander on Mars. It landed on Mars in July of 1976, and it survived for 6 years. This right here is the first color image taken from the surface of Mars. The flatness here is quite apparent. Viking I landed in this area. It is right where there are a bunch of these flow patterns caused possibly by water. There is also evidence that Mars in the past had an ocean, and the likely location of that ocean is in the Borealis Basin. A certain type of deposit was found along the rim of Borealis Basin. That type of deposit is also found on Earth, and it is associated with tsunamis. Even the impact that likely caused the ancient tsunami on Mars was found. That is the Lomonosov crater that is around 100 kilometers in diameter. The Viking I lander also landed near a formation that was quite possibly carved out by water. The Kasei Valley is one of the largest outflow channels on Mars. Taking a closer look at just one of the locations in this valley reveals countless flow patterns. This image in particular showcases just how aggressive the flow patterns are. It is estimated that the volumes of water that are needed to carve out the type of channel right here on Mars is equivalent to some of the largest known floods on Earth. Here is another image showcasing a channel that is situated between the very pronounced flow patterns. Here is another one showing a 40-kilometer wide channel in the same region. This image showcases the odd labyrinth-like terrain that is located in the valley. Lots of strange patterns were made here, possibly due to the flooding. All of these satellite images of Mars were taken by NASA's Mars Reconnaissance Orbiter that arrived on Mars in 2006. It is still operational. Nearly every satellite image in this video will be coming from this orbiter. NASA's Viking II lander is the second successful lander on the surface of Mars. It landed in September of 1976, about 3 months after Viking I. Viking I and II are also twins, as in they are pretty much the same model. Viking II, unlike Viking I, lasted much less. It survived for 3.5 years. This is a panoramic view captured at the landing site. It showcases a very flat landscape filled with a bunch of boulders. This color image from Viking II showcases the extremely fine frost that appeared on the surface. Here is another color image from the landing site showing the extremely flat landscape. Viking II landed very much directly in the Borealis Basin, specifically in the Utopia sub-basin. At about minus 4,500 meters of depth, it is the lowest point at which any successful lander or rover landed on Mars so far. Although a depth of minus 4,500 meters is very similar to the depth of every other lander and rover that is directly in the Borealis Basin region. Because of the depth that the Viking II is in, it also managed to record at a certain point a surface pressure of about 1,080 pascals. For some comparison, the average surface pressure on Mars is 610 pascals. So the surface pressure at the Viking II landing site was nearly double the average. However, it is important to note that the surface pressure varies even on the same place on Mars as the seasons change. The lowest surface pressure Viking II recorded is around 750 pascals. The reason that the pressure varies by season is due to the fact that a huge chunk of carbon dioxide in the atmosphere gets frozen during winter on the poles. That causes the air pressure to drop. Then, as the winter leaves and carbon dioxide starts vaporizing, the air pressure goes up. Now, the depth of minus 4,500 meters is established through the comparison to the Martian datum, which is the 0-meter reference point for Mars. It is akin to the sea level being the 0-meter reference point for Earth. Now, the average depth in the Borealis Basin is about minus 4,000 meters. However, some craters in the basin go even way below that point. In the crater called Leot, a certain spot has a depth of minus 7,100 meters. That depth makes it the deepest point in the Borealis Basin. However, that is not the deepest spot on Mars. That goes to the Badwater crater at a depth of minus 8,500 meters. This crater, however, is located in the Hellas Basin, which is in the highly cratered southern hemisphere. One somewhat interesting thing about the craters found in the Borealis Basin is that a huge number of them have this additional circular zone around them. For some reason, the craters in the southern highlands very rarely have that additional zone around them, and when there is one, it is much smaller. In July of 1997, NASA's Pathfinder lander successfully landed on Mars. It is the third successful lander on the surface of Mars. It survived for nearly 4 months. Here is a color panoramic view of the landing site. This one is not very flat. Even some hills can be seen in the distance. And what can also be seen in this panoramic view is a rover called Sojourner taking a spectrometer measurement of a rock. This tiny solar-powered rover that is only half a meter long is the first rover on the surface of Mars. It was deployed from the lander. Although it only traveled a little over 100 meters, it still was very useful as it paved a way for future rover missions on Mars. The Pathfinder lander, just like Viking I, is also located in the massive flow pattern region. It is only about 800 kilometers away from Viking I. Pathfinder is close to this massive formation where there are these elevated patches of surface. A closer look reveals that the patches have very sharp edges. They are typically between 500 and 1,000 meters above the surrounding terrain. At the end of one of the outflow channels in this region is this bizarre-looking terrain. That, however, is not the most chaotic-looking region in these outflow channels. The largest crater in this flow region is filled with extremely chaotic terrain. In some parts, there are huge blocks, while in others, they are relatively tiny. Zooming in even further reveals to what extreme extent the chaotic pattern is present. these large outflow channels are also connected to the largest valley on Mars. That is the Valley Marineris. It is about 4,000 kilometers long and around 200 kilometers wide. That also makes it the largest valley in the solar system. It is also extremely deep. It typically has a depth of around minus 4,000 meters. However, the surrounding terrain is typically plus 4,000 meters high. In this specific region where this image was taken, the difference is even greater. From the floor of the valley, the wall of the valley goes around 9,500 meters above. This is one of the tallest structures that can be seen directly from the surface in its entirety in the solar system. In May of 2008, NASA's Phoenix lander successfully landed on Mars. It is the fourth successful lander on Mars. Here is a panoramic view of the landing site. Compared to the location of previous 3 landers, the rocks here are quite small, and the landscape is astonishingly flat. Although really far into the distance, some hills can still be seen. This is currently the most northern location that has been imaged from the surface of Mars. This landing location is about 800 kilometers away from the permanent North Polar ice cap of Mars. When the Phoenix lander scooped up the soil, what was revealed were fragments of ice that then sublimated. Additionally, one camera also captured the view of the surface directly underneath the lander, and what can be seen is a bright patch that is quite possibly ice. After 6 months of operating, the lander went into safe mode, as it was getting too little sunlight. Although the mission ended in October, attempts to contact the lander again were made successfully in November again. But after that point, a dust storm appeared in the area, and that reduced power generation even further, and any contact was completely unable to be made. The area that the lander landed in also becomes a part of the North Polar ice cap every winter, since when the freezing temperatures come there during winter, carbon dioxide starts freezing there, which then coats a huge chunk of the surface in the north with dry ice. Images from orbit also showed the lander encased in dry ice during winter. The estimate is that the dry ice was around 19 centimeters thick. It probably damaged the solar panels as well. There are also areas around the permanent North Polar ice cap that are not a part of the ice cap but also have permanent ice. A good example of that is a crater called Korolev. This crater is 80 kilometers in diameter. Close to the rim, it has a depth of minus 6,000 meters. However, most of the surface of the crater is elevated. There is this huge pile of ice taking up most of the surface of the crater. The pile is around minus 5,000 meters of depth, so 1,000 meters above the surrounding edge. The shape of the crater there changes the temperature such that it allows for permanent water ice to reside. The North Polar ice cap itself has some pretty amazing areas. One of these is this area with this huge valley that cuts deep into the ice cap. Here is one image which showcases this wall. It is around 1 kilometer tall. It looks pretty neatly layered. And right next to the wall are a bunch of these pits, likely caused due to sublimation. The entirety of the North Polar ice cap stands typically some 2 kilometers above the Borealis Basin. It also takes up an area of around 1 million kilometers square. Although the ice cap is indeed coated in dry ice, that layer is very thin, at best only a couple of meters. Most of the polar ice cap is made up of water ice. NASA's InSight lander landed on Mars in 2018, making it the 5th successful lander on Mars. The lander lasted for 4 years. Here is a panorama from the landing site. Although the rocks here are larger than the ones in the region Phoenix landed in, they are still a lot smaller compared to the region Viking I, II, and Pathfinder landed in. InSight landed between a massive volcano named Elysium Mons, in the elevated southern terrain. It's only about 550 kilometers away from the Curiosity rover that landed in 2012. Another thing that is somewhat close to the InSight lander location is this terrain. It is filled with a bunch of parallel flow lines. The InSight lander is also close to Elysium Mons. This volcano has a peak that is 14 kilometers above the Martian datum. That makes it the 5th tallest mountain on Mars. Right next to it is also this odd-looking valley. It is 200 kilometers long and has a width of 15 kilometers. This is how it looks like up close. Currently, the last rover that landed directly in the Borealis Basin is a rover made by the China National Space Administration. It landed on Mars in May of 2021, and it survived for 1 year on Mars. After May of 2022, the contact with the rover was lost. Very close to the location of this landing site, just a few tens of kilometers away, there is this location filled with a bunch of domes. Sadly, it didn't reach this region as it traveled for about 2 kilometers. Close to Elysium Mons is a massive mountain range called Phlegra. It is 1,300 kilometers long. Although most of the mountain range is below the Martian 0-meter reference point, some points still are above it. Some of its tallest peaks rise around 4 kilometers above the surrounding plain. How it formed is not entirely certain. Some ideas are that it is a rim that is a part of an ancient crater. The rest of the rim just disappeared. Still, there is not much evidence for an impact here. Another idea is that this is actually a mountain produced by past tectonic movement. Whatever it is, it definitely sticks out, as Mars doesn't have too many mountain ranges. On the northern part of the Phlegra mountain range, a newly formed impact was discovered. And what the impact crater reveals is ice. It was buried for likely many millions of years. It's also possible that there are many other locations like this one on Mars, where below the surface there is a bunch of ice. Going a bit more south, there is this very odd-looking feature on Mars called Orcus. It is an elongated depression. It is about 370 kilometers long and about 120 kilometers wide. This image was taken by the Mars Express orbiter, which was made by the European Space Agency. It reached Mars at the end of 2003, and it is still operational. The image showcases the rugged mountains surrounding the extremely flat plains. They are around 2,000 meters above the floor of Orcus. Overall, it is not exactly known how this feature formed. Some ideas suggest that the origin is tectonic, others volcanic. There are other ideas as well. Going even further south, right at the border of the Borealis Basin, there are these two massive ridges, both around 1,000 kilometers long. The one on the left has some very odd-looking pattern. As we can see from this image, there are these weird-looking gullies. They all display the same structure. It's like they are copy-pasted. With regards to the ridge on the right, this is how it looks like up close. There is this extremely sharp wall, and then at the top of the ridge, there is this enormous cliff. Next, let's look at Olympus Mons. This is the tallest mountain on Mars and the tallest planetary mountain in the solar system. It is about 22 kilometers above the Martian datum and above the surrounding terrain. Although most of the mountain is a pretty flat slope that gradually elevates up to the tallest point, the sides of the volcano are not like that. They are extremely steep. One side in particular is really exceptional in this regard. On this side, the wall is 10,500 meters above the floor. This is one of the tallest structures that can be seen directly from the surface in its entirety in the solar system. Here is how this place looks like from a satellite. There is this very flat floor, and right next to it is this extreme protrusion filled with gullies. A bit to the west of Olympus Mons, there is this massive flat region, and this one is even a lot more flat compared to the rest of Borealis. This close-up image in the region showcases just how absurdly smooth it is, and it goes on like this for thousands of kilometers. Besides all of the mentioned rovers and landers, which landed directly in the Borealis Basin region, there are also rovers that landed right at the parts which can be considered the border of the basin. In January 2004, NASA's Spirit rover landed in the crater called Gusev. It is very close to this massive ancient volcano. Here is one panorama from the rover, captured at the top of the hill that is right in the center of the crater. The massive plain of the crater is visible quite well. The rim of the crater that is 70 kilometers away is also visible. Also in January of 2004, but around 20 days later, another rover landed at the equator, but 9,500 kilometers away. That is the Spirit rover's twin, called Opportunity. It landed in this zone that gradually elevates from the flat plains of Borealis to the southern highlands. Here is one panorama that this rover captured of the crater called Endeavour. It is 20 kilometers in diameter. Out of all of the successful rovers and landers, this rover is also currently at the highest altitude on Mars, at around minus 1,300 meters. So yes, it is still way below the 0-meter point, however quite a bit above the Viking II lander, which is at minus 4,500 meters of depth. On top of its record altitude, it is also currently the longest surviving man-made object on the surface of Mars. It survived for 14 years. In August of 2012, NASA's Curiosity rover landed in the crater called Gale, which is also right at the border of Borealis. It is about 2,200 kilometers away from the location of the Spirit rover. Here is one image of the central peak in the crater from the rover. The peak rises around 5 kilometers above the floor of the crater. As this rover is still active, currently it is climbing this peak, and it is some 750 meters above the landing location, which is the floor of the crater. The Curiosity rover still has plenty of nuclear power left. However, it's still not certain that it will reach the top of the central peak. Maybe its wheels will give out, or it will possibly get stuck in something before it reaches the top. However, there is still that chance that it actually reaches the top, and if it does, then it will be about 400 meters above the 0-meter point on Mars. In February of 2021, NASA's Perseverance rover landed in the crater called Jezero. This rover is currently active, and it likely has plenty of years left. Here is one panorama nicely showcasing some of the landscape that is present in this location. In the distance, a mountain can be seen that is 50 kilometers away. It rises about 2 kilometers above the floor of the crater. Also, Perseverance rover is very close to this massive dark spot. However, that is not a part of the Borealis Basin, so that is a topic for another time. However, there is also a pretty dark spot directly in the Borealis. Although it isn't visible while looking at a topographic map, a close to real color image shows it quite well. Here is how this spot looks like up close. Overall, it's extremely hard to cover everything interesting with regards to this massive basin, and considering that it is the size of 1/3 of all of dry land on Earth, that is to be expected. However, it's also the case that most of this massive area is very simple. It's just an enormous plain. Still, because there are some indications that there was once an ocean here, that is possibly at least one reason as to why this northern basin got so much attention, and with that why it has most of the landers and rovers. The potential to find evidence for past water, possibly past life, is quite enticing. However, that leaves the southern highlands of Mars very much unexplored. There were still some attempts to have landers in the region, but all of them were unsuccessful. Hopefully, we are eventually going to get to see how this region of Mars looks like from a lander or a rover.